So when you hear the word robot, what pops into your head? Probably something from a sci-fi movie, right? Or maybe a huge industrial arm in a factory. But here's the thing. All of them, from the really simple ones to the super complex, they're all built on the same three core ideas. And today, we're going to break down that exact blueprint.
All right, let's start with a little thought experiment. What could a super expensive Mars rover, the one crawling around on another planet, possibly have in common with a Roomba that's just bumping into furniture in your living room? I mean, they couldn't be more different, right? But believe it or not, they actually share the exact same, let's call it operational DNA.
And the answer is, well, it's actually pretty simple. It turns out both of those machines, and really every single robot out there, operates on the same three pillars: sensing, thinking, and acting. That's it. That's the universal blueprint for any intelligent machine. Okay, so let's dive into that first pillar, sensing the world. It makes sense, right? Before a robot can do literally anything, it has to understand what's going on around it. It's got to get some input. And when we say sensing, it's not just about seeing or hearing. The real trick here, the core of this whole pillar, is taking our messy, chaotic, physical world and translating it into neat, organized data, something a computer can actually understand and work with. The easiest way to think about it is to just think about us. For a robot, sensors are its eyes, its ears, even its sense of touch. They're basically its windows to the outside world.
And we can give robots all sorts of senses. You've got cameras, obviously, which are like our eyes. Then there's something called LiDAR, which is super cool. It shoots out invisible laser pulses to measure distance with insane accuracy. It's kind of like a built-in superpower for getting around. And then you have things like pressure sensors, which can give a robot a really fine-tuned sense of touch.
All right, so now the robot is just getting flooded with all this data from its sensors. But that data on its own is pretty much useless. The robot has to figure out what it all means. And that brings us to pillar number 2, the robot's brain.
So this is the thinking part. The robot takes all that raw data and runs it through algorithms, which are really just a set of instructions, a recipe, to figure out what to do. The goal could be as simple as clean this room or as big as look for signs of water on Mars. This is where it makes the call on what to do next.
And if we go back to our human analogy, if the sensors are the eyes and ears, then this whole processing part, well, that's the brain. It's the command center for the whole operation.
Now this brain really has two sides to it. You've got the hardware, like the computer processor that does all the number crunching, and then you have the software. And honestly, the software is where the magic happens. Those algorithms we talked about, they're the key. They're the instructions that tell the hardware how to turn all that sensor data into an actual decision. Okay, so let's imagine our robot. It sensed a wall, its brain has processed that, and decided, okay, I need to turn left. But a decision is totally useless if you can't do anything about it. And that leads us right into our third and final pillar, from thought to action. Yep, after all that sensing and thinking, the robot needs some muscles. It needs a way to actually move and interact with the world based on what its brain just decided.
The fancy technical word for these muscles is actuators. And all they are really are the parts that take the electrical signals from the brain and turn them into actual physical movement. An actuator is what bridges the gap between a digital command and a real-world action.
You see these everywhere? The motors that spin the wheels on your Roomba? Those are actuators. The pistons that push a giant factory arm back and forth. Actuators. Even the gears that transfer all that power. They're part of the system. This is where, the rubber literally meets the road. So, we've broken down all three pillars: sensing, thinking, acting. But here's the most important part. The real genius here is that these aren't just separate steps. They're all part of a never-ending loop. And this is how it works. It's simple. Step 1, sense. The robot's camera sees something in the way. Step 2, think. The brain looks at that image and decides, whoa, gotta turn. And step 3, act. The brain zaps a signal to the motors and the wheels turn. Sense, think, act. But it's not just a one-and-done thing. The real beauty of it all is that this loop is continuous. It can happen hundreds, even thousands of times a second. That's what lets a robot react and adapt to a constantly changing world, just like we do. And here's the crucial part that makes it a loop. The second the robot acts, even if it just turns a tiny bit, the whole world looks different from its new perspective. It has new information coming in. So what does it have to do?
It has to start all over again. Sense this new reality, think about it, and act again. It's a cycle that just keeps going and going. So there you have it. The 3 pillars that make a robot, well, a robot. Sense, think, act. But knowing that just opens up another really interesting question, doesn't it? What are all the different ways that robots can actually move?
So we've pretty much covered the what and the why of robotics. But next time, we're going to dive deep into the how. We're talking the nitty-gritty mechanics and engineering behind how these things get around.
Yeah, we'll be looking at the 3 big ones you see out there. We're going to talk about wheels, which are super efficient. We'll get into legs, which are way more complex than you'd think. And we'll even cover the awesome freedom of flight.
So, I want to leave you with a question to chew on until then. Out of those 3, wheels, legs, and flight, which one do you think is the hardest for engineers to get right? Give it some thought. We'll dig into all of it in our next explainer. See you then.
Please like and subscribe to Think Tank 2.0, where knowledge is power.